4-3, solving systems of equations by elimination. So we're going to do a few examples of elimination to do this. So what you're looking for elimination, you're looking for two equations like this that are written in a way where you have the x and the y together on one side and a number here at the end. So if you guys remember, there's a formula called ax plus by equals c. We called it standard form. You want the equations to be like this. And the reason is you're going to combine them. Now, the catch is you want one of the numbers to cancel out the other. So the way you cancel it out is one is positive and the other one is negative. So when you combine these, you're going to add these up and these will cancel out and you're only going to be left with x's to solve, okay? So you're adding together the two equations to make a new one. That's basically the concept. So let me give you an example. Right here, we're going to add this up. So I'm going to line up my equal sign, and you're going to notice my x's line up and my y's line up. So everything lines up one on top of the other. Now, when I add these up, 1 plus -6 would be a -5. 3 plus 2y, these would be 5y. And right here, 2x plus -2x, well, if you add it up, this will cancel out. So there's no x's to solve anymore because they're gone. Now you just have this. Divide by 5, y equals -1. All right, now remember, you need an answer for x and y. So what you do is you go back to one of your problems. Let's just take the top one. Take one of the equations. You're going to plug in -1 into the y. Like this. Then what happens, this multiplies. And now you're just solving for x. So I'm going to move the 3. I divide by 2. And my answer is x equals 2. So my answer for this system is 2, -1. And guys, that's solving by elimination. We added the two equations together to make one problem. Once we solve for that one, we plug in the answer and solve for the other variable. And that's it. That's how we do elimination. Now there are some complications to it. So for example, here, you notice they don't line up. The equal signs don't line up, the y's don't line up, the x's don't line up. In this situation, it is your job to rewrite the problem to make it line up. So for example, I need that x to be over here, so I'm going to move that x over. And then what I end up with will be a -x and the 4y, and the 3 is only on that side. I do not change the top one. The top one I leave alone. And now when you look at it, the x's line up, the y's line up, and the equal signs line up. It's very important that they line up when you do this. All right, so let's add them together. So we're going to combine them. We're adding it all up. So we're going to get 5. The y's cancel out here. 2x plus a -x, that's 1x. So we have 1x equals 5. The 1 really doesn't matter, so x equals 5. Okay, now we're going to go back to this one, okay, this equation. Since I now know what x is, I'm going to plug in my x into here, so I get 5 plus 3. That's 8. Then I solve for y, divide by 4. I get y equals 2. So my answer for this one would be 5, 2. So it's still elimination. I'm still combining them to eliminate the y, and I'm still plugging in the answer to find the other one. I just had to do a little bit of extra work first. Okay. So let's practice some more. Now, sometimes they line up, but if you add it up right now, nothing happens. So don't copy this, but here's what would happen if you add this up. You would get 3, negative 3y, and 3x. Now, this is what you don't want to happen. This should not happen because nothing eliminated. The x didn't eliminate and the y didn't eliminate, or the y didn't eliminate. One of these variables should eliminate. So in these cases, we're going to have to change one of them so that something does eliminate. So, for example, I can't make these eliminate, but maybe I can make the x's eliminate. Now, how would I do that? How would I have the x's change? Well, what you can do is you can actually multiply the entire equation and put whatever number you want with x and whatever number you want with y by multiplying. So right here, I want a 2 to cancel out this 2. But to cancel it out, it can't be a positive, it needs to be a negative 2. So I'm going to multiply everything by negative 2. Everything in that top equation is going to multiply by negative 2, and that way I get this. Negative 2x, negative 4y equals negative 8. And now, you see that? That's going to eliminate. The y's won't eliminate, which is fine. You only need one of them to eliminate. And now I can combine these. So I would get negative 9, negative 9y, and the x's are gone. So I get this problem. I'm going to solve for y. I'm going to divide by negative 9. I get positive 1. Then I go to the original problems. I'm going to pick the top one this time. So I'm going to pick this one. I'm going to replace the y with a 1. Substitute it. So 2 times 1 is 2. Now I got to get rid of that 2. So inverse operations. And I get this answer. So these are my two variables, x and y. My answer as a coordinate would be 2, 1. Elimination. Okay. All right, take a look at this one. So a couple things here, they don't line up. So I'm going to change the top one. I'm going to move this. I don't like the way this looks. So I'm going to move the 2x to be over there. So I'm going to do a plus 2x. And then when I do that, I get 2x plus y equals 2. Okay, now that's my new problem right here. So I changed the top one. The top one is now this. I'm going to leave actually the bottom one will stay the same. I'm going to leave it the same. So these are the two problems I have. Now, what do I want to eliminate? I could put a 2 here, but I have to multiply the whole thing by negative 2, or I can eliminate the y. What number do I need here? Well, since this is a negative 2 right here, what I can multiply this is just by a regular 2. If I take this entire problem and I multiply it by 2, so let me show you. The entire problem, but I want a 2 in here, so I'm going to multiply the entire problem by a 2. I'm going to multiply, so I distribute. I'm going to get 4x plus 2y equals 4. Then, if this was underneath it, the same way, right there you see it's going to eliminate. That's gone. And what's left is a 5x and a negative 1. Ooh, it's going to be a fraction. So x equals negative 1 over 5, 1/5. Okay. I want to make sure I did this correctly. Normally you'll get whole numbers. Occasionally this does happen, but remember, all you do is you're going to plug it in. So I'm going to take that top equation. I'm going to replace the x with negative 1/5. This multiplies. So I get 2/5 plus 2, because the negative times the negative makes positive. And my y equals 2 and 2/5. When I add up 2 plus 2/5, I get this. So my coordinate, negative 1/5, and 2 and 2/5. That's my x and my y. This would be my answer. Okay? All right. Now, number 3 is a word problem. So let me, a florist is making a bouquets. Okay, he's making regular bouquets and mini bouquets. The florist has 118 roses and 226 peonies to use in the bouquet. How many of each can he make? So it's a little confusing because you think you're solving for roses and peonies separately, but you're not, because the totals are the flowers. So for roses, you have 118. That's going to be a total. So you're going to set that equal to 118. For peonies, you have 226. So you're going to set that up at 226. Okay, but how many of each kind? So the way we're going to differentiate is a regular bouquet and a mini bouquet, okay? So what we're going to say is, instead of x and y being the flowers, we're going to have x be the regular bouquets, and we're going to have y be the minis, okay? So when we set this up, it's going to look something like this, okay? For the regular bouquets, it's 5 roses, and for the mini, it's 3 roses. So it's going to be 5x for the regular and 3y for the mini. For the peonies, it's 11 goes with the regular and 5 go in the mini. And ladies and gentlemen, this becomes our equation. So let me move this up a little bit, right there. And this is how we're going to solve for the number of flowers using this equation. Now, you notice they don't match, so we have to make them match. Now, in these cases, what you have to do is you have to multiply both of them to make something match. Now, if I do 5 and 11, if I multiply this and this would make 55. That's going to be a really big number. But 3 and 5, I can make this match by turning them both into 15. If I multiply this one by 5 and this one by 3, these numbers will be 15, okay? So let's work that out real quick. I have 25x plus 15y equals 118, 590. If I multiply this one by 3, I get 33x plus, actually, you know what? I'm going to make it a negative. Negative 33x, negative 15y, and the reason I'm making it negative is so that it cancels out when I add it up. So that will help me solve this. If I make one of them negative, it'll cancel it out when you add it up. Okay, so I just multiplied them. The 15y's will cancel out. I'm going to be left with negative 8x, and on the other side, I get negative 88. I divide that by negative 8. I get x equals positive 11. Okay? Take that 11, plug it into the original problem. So that's 55 plus 3y equals 118. 118 minus 55. Both sides. I get 63. Divide that by 3. I get 21. So x equals 21. So, sorry, y. There's your answer. Now, what does this mean? Remember the scenario. X is the regular case. So we have 11 regular bouquets and 21 mini bouquets. Okay, so remember what they represent in a word problem. Okay, last problems. Choosing a strategy. Now, guys, I'm going to let you guys work this one out. But in this case, when you look at this problem, you now have an option of choosing graphing, substituting, or elimination. Now, in this case, what would you choose? Okay, and then we work it out here. In this case, what would you choose? And then let's work it out here. Okay, and this is kind of practice. That's it.